All right, let's take a look at our lesson for today. This is starting chapter 7. This first section in chapter 7 is on inverse trigonometric functions. So I would like to start by just talking about inverse functions in general, just kind of reminding you, we dealt with them last year. What's an inverse function? So the property is we switch the x and the y values. If you remember, that's what we do to get the equation. And the graphs of the function and its inverse would be symmetric over the line y equals x. So let's look at, I'm just going to remind you an example. Let's say, we had say y equals, I don't know, 3x squared plus 1. Okay. So what do? We switch the x and the y first. So we would say x equals 3y squared plus 1. And then what we would typically do is we would solve for y. So I would move the 1 over, divide by 3, and then square root both sides. So y would be plus or minus the square root of x minus 1 over 3. And this, we would typically put y to the -1, just to show that that is like the inverse. Why the -1? This is like a little notation that indicates that's an inverse. Okay, so just a reminder. Remember that? We're okay? So that's just in general what inverses are. So you can see that's exactly what we're doing here, where if we had sine of y equals x, and we just flipped it around, it would be arc sine of x equals y. So that's the relationship between them. So just an example, another example. So this would be like, well, so what if I had sine of pi over 2? We know, let's do pi over 6 instead. Okay, so sine of pi over 6, we know that that equals 1/2. Okay, from our unit circle, work with unit circle. So the way that we would write it with arc sine, or sine to the -1, we would say sine to the -1 of 1/2 equals pi over 6. See how they just the x and the y values have flipped. They're not inverses, or reciprocals of each other. It's not like you flip them upside down. It's that you really are changing the x and the y values. You're just flipping where they are. Okay, so that's just kind of a reminder. So we did get into, inverse trig last year in some classes, maybe not in others, but that's just a kind of a reminder where we were. This whole, what do we call? So our table right here is really like a reference table for you. Okay, I'm not going to go through and talk about every single thing in the table, but it's kind of a reference for you. If you want to look at domain and range values for the inverses, they are located here. One thing I do want to point out down here in the bottom is this, just a note, just a kind of a fun fact, if you will. We know that sine and cosecant are reciprocals of each other. So in other words, cosecant theta is the same thing as 1 over sine theta. And this is just kind of okay. Well, there we go. I guess it's tired. Are you ready? There we go, sine theta. Okay, so it's just kind of an interesting concept that we can make those two equivalent. Cosecant 2 over 1 is the same as sine of 1 over 2. We're not like doing the reciprocal or flipping sine and cosecant upside down. We're actually flipping their arguments upside down. And that's just kind of a fun fact, that those are the same. Those two values would give you the exact same value if you put those in your calculator. We're not going to be doing very much of that, but I just wanted to be sure to point out that that is certainly okay. That is a thing. All right, so let's get down and talk about the graph, why we have to do this, why we have to do this whole chart right here. Okay, so this is referring to principal values. It's called principal values, which are function values. So let me explain why we need that. I want you to understand why we need that. Why do we have to add this wrinkle to our work? So and we knew how to graph sine. We've been graphing it for a little while, right? This would be sine. You know it goes forever in both directions. That's sine. If I were to flip the x and the y values in this, I would get something that, you know, looks like this, right? Is that a function? It is not. So because that is not a function, mathematicians a very long time ago decided to restrict the inverse function to make it a function. Otherwise, it's an inverse relationship, right? Because that's not a function. So that's why all of these restrictions are in place that you see over here. You know, the inverse sign only goes negative pi over 2 to pi over 2. So what did they do? They basically took this graph, and let me scoot it over just a little bit. Okay, so they took this graph and they restricted it. They made it to where the inverse sign only goes like this. There's only that much of it, just a little bitty piece. Because if I kept it going in either direction, wouldn't it just double back on itself and not be a function, right? So that's what they've done. They've basically made the inverse sign, if you want to say start at negative pi over 2 and end at pi over 2. Those are the y values. This is y value. That's why the range is from negative pi over 2 to pi over 2, because that's where they decided to restrict it. You can see you can pick any other section, but we wanted as mathematicians to be consistent, and so that's what was decided. Your calculator is programmed for this information. It's only going to generate numbers in that interval. It doesn't know how to generate numbers like way out here. It doesn't know how to do that. Okay? So you are definitely smarter than your calculator. All right, so that's I'm hoping that's why the understanding of why we have to have principal values. We have to cut those values off so that we have a function. So because of that, bless you, because of that, what we've got up here is locations where each of the functions belong. So what I'm going to do is I'm just going to start with these. We're going to just highlight this in blue. Arc cosine, arc cotangent, and arc secant belong in these two quadrants. Okay? So in this quadrant is when the values are positive. And what I mean by the values is, for example, arc cosine of, say, I don't know, 1/2. Okay? That's what I mean by positive. That's the number we're looking at, the x value of the inverse functions, positive. We're going to be in the first quadrant. If that number is negative, we're going to be in the second quadrant for these three, arc cosine, arc cotangent, arc secant. So this example of this would be like, what if it was arc cosine of negative 1/2? Then that would exist, that angle measure would exist in the second quadrant. Okay, so if arc cosine has a negative side measure, that, you know, the x value, then its angle measure is going to be in the second quadrant. There's no other choice. If that's positive, this is, of course, quadrant 1, then those are going to be in quadrant 1. Okay, so let's investigate these other three. So the other three, the arc sine, arc tangent, arc cosecant, they belong in these two quadrants. So when for example, if we have, and I'll write it kind of up here, if we have arc sine of root 3 over 2, that's going to be in quadrant 1, because that's a positive number. Root 3 over 2 is positive. If we have arc sine of negative 1/2, that's going to be in quadrant 4. That's where the angle measure is going to reside, in quadrant 4. And there's a little bit of a wrinkle to this. I hate to add this for you, but that angle measure is going to be negative. We have to rotate backwards to get into quadrant 4. We have to rotate backwards. That is shown here by this graph. See, these angle measures over here are negative. Also, one way that I remember is by thinking to myself that you cannot pass through quadrant 3. You can't be in quadrant 3 to be a function, and you can't pass through quadrant 3. So it's how it kind of rationalizes in my head how I can remember that to get to quadrant 4, I have to go backwards. I have to, so it's a negative angle measure. So in quadrant 4, these are negative angle measures. And that, so if arcsine or arctangent or arccosecant has a negative in the argument, okay, this is called the argument right here, then we're going to be in the 4th quadrant and the angle measure is going to be negative. Now I know that is a lot. I'm explaining a lot of stuff to you. I'm hoping over time it kind of just embeds in your brain and this makes sense. And you're able to like internalize it, so that makes sense. But the reason that we have to go through this crazy mess is so that we can have principal values, function values. That's what we want. And in order to do that, we have to basically cut out a lot of answers. Does that make sense? We have to cut out a lot of answers. We can't have all of this as an answer. That's not okay. That's not, that's a relation. It's not a function. Okay, I'm going to pause there for just a moment. So we talked about the concepts that we're going to be working with today. Are there any questions about the concepts that we're going to be working with today? Okay, so let's move to our example page. So we're going to use these concepts. All right, so find the exact value in radians. So we note that this is radians. Okay, great. So the first thing that I like to do is I'd like to determine which quadrant I'm looking for. Which quadrant? That's very helpful to me. That's just helpful to me. So this number is positive. Since that number is positive, which quadrant will we look for angles for cosine since that number is positive? Quadrant 1. So I'm just going to write that note up here. I'm going to be looking for an angle in quadrant 1 for that. So let's think about it. Let's remind ourselves about the unit circle. So you recall the unit circle is so important. We're going to be looking at it for all this year and next year. So the root 3 over 2 and 1/2 belong with the 30, 60, 90s, right? 30, 60, 90s. Do we remember in our unit circle, what do we count in for the 30, 60, 90s? Pi over 6. We count in sixths for the 30, 60, 90s. Remember that? What do we count in for the 45, 45, 90s? What do we count in? Fourths. We count in pi over 4 or fourths. All right, so we've got that down. So this is the root 3 over 2 we know is a 30, 60, 90. And cosine maps with, does it map with the x or the y? It maps with the x. Now we know that root 3 over 2 is bigger than 1/2. So this angle is in the first quadrant and it's going to lie flatter against the x-axis because the x is bigger, right? Root 3 over 2 is bigger. And we know it's 30, 60, 90, so we're going to count by sixth. So this is basically 1 pi over 6, right? So my answer to this is pi over 6. Okay, questions so far? All right, so I hope that you see the pattern that I'm doing, and I do the same thing every single time. It's not like I change for different problems. We're going to do the same thing every time. So we're going to focus on, so we're going to look at this number right here. That number is negative. Now I need to think to myself, where would I be looking for angles for sine when that number is negative? We look up here on our chart. Where would we be looking? Quadrant 4, right? Quadrant 4. So I'm going to write that down. So we're going to be looking for an angle in quadrant 4. And also these angles are backwards. This is a backwards rotation. I'm just making myself notes. No sense in jumping into the problem unless I know exactly what I'm doing. Okay, so we're looking for quadrant 4. We're looking for a backward rotation. All right. So let's go to quadrant 4. Now root 2 over 2, all the root 2 over 2's, which special triangle does that map to? 45, 45, 90. So we're talking about right here, right? And we count in pi over 4s. Now, I am not allowed to go through here. I'm supposed to go backwards. So this would be 1 pi over 4, negative 1 pi over 4. Okay, are we okay so far? All right, so my answer is negative pi over 4. Okay, yes, ma'am.
So I get confused like with the counting. So can you just look at the unit circle and see like which one would add up? Could you do it that way too? Or do you have to do it like counting?
With the counting? So if you, so for the rest of our stuff, you won't have a unit circle to work with. You won't be able to look at it. So what students do sometimes is they draw out the whole unit circle on their paper. I understand why a student would want to do that, but that takes time.
Yeah.
And so if you're in like a testing situation and you spend 5 or 10 minutes drawing out the unit circle, then you're taking time away from working problems. So if we're counting, let's just work on the counting for a moment then. Okay, if we're doing root 3 over 2 or 1/2, those are 30, 60, 90. And so I would count in sixths. So I would count 1 pi over 6. I would count 2 pi over 6. I would count 3 pi over 6. I would count 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. If it's these numbers, root 3 over 2 or 1/2, I would count in sixths. Okay? If it's root 2 over 2, I would count in 1/4. So that would be 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Notice how I count the x and y axis every time. 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4 would put me back here. Okay, so the 45, 45, 90s only have one angle in each quadrant, and the 30, 60, 90s have 2 angles in each quadrant. Okay, so this is the 45, 45. So what I'm hoping is over time, that will solidify like, you know, in your brain, and that becomes natural for you. It becomes natural to count because that's going to make your life easier. Does that make sense? Are we okay? Okay. All right, now on C, that's tangent, and unfortunately tangent isn't just like sitting out there with root 3 over 2 or 1/2 or root 2 over 2. It's weird because it's a combo, right? Tangent is a combo. It's a combination of sine over cosine. That's what it is. And in order to get a root 3, I'm going to have to use the 30, 60, 90s, right? That's the only one of those that has a root 3. To use 30, so I would need, in order to end up with a whole root 3, I would need sine to be root 3 over 2, and I would need cosine to be a half. And of course, one of those has to be negative. So let's talk about, so this is negative. Where is arctangent? At what quadrant would we be looking for an angle for arctangent? Quadrant 4. So this, we are going to be looking at quadrant 4, which means backwards rotation. Okay. So here's what we want to do. So we want to be in quadrant 4. Let's see, what sign would be negative there? Okay, so sine is the bigger one. Since sine is the bigger one, we want this to be longer along y because sine maps to y, right? Sine maps to y. So we want it to be longer. So I've got an angle, a 30, 60, 90 angle here where I have that dot and another one here. So now I'm counting backwards. I count the same thing, but I'm counting backwards. So it's a 30, 60, 90, so I'm counting by 6. So this would be negative pi over 1 pi over 6, negative 2 pi over 6. I mean, if I wanted to keep going, negative 3 pi over 6 and so forth. I mean, I don't have to. I'm just saying that's what you would do. You would count all the way around backwards. And so this angle that I want where sine, where the y value is bigger, that means it's more long along the y-axis, would be negative pi over 3. Okay, how are we on those? Will we be able to handle those? Yes, ma'am.
How would you know, like, which, like, I know how you got, if it was a 30, 60, 90 or 45, 45, 90, but how would you know which, like, before graphing, which point, like, which points would be cosine, which one would be sine?
Okay, so in order for a good question, so let's think about our complex fractions. So I have root 3 over 2 over 1/2. If I fix that, that's going to be root 3 over 2 times 2 over 1. The 2's go away, and I'm left with negative root 3, which is what I have right here. That's what this is. So that's why I knew that the sine had to be the root 3 over 2, and the cosine had to be the 1/2. Okay, if this had been 1 over root 3, because those are your only choices with the 30, 60, 90s for tangent. It's either going to be root 3 or 1 over root 3. So if it's 1 over root 3, what order would that sine and cosine have to be in? What would this have to be in? Sine would have to be yeah. Well, sine is going to stay on the top because that's its thing, but you're right. So if the ratio is like this, if sine was 1/2 and cosine was root 3 over 2, this simplifies to be 1 over root 3. So those are really the only two possibilities for us here to get the root 3's. If it's root 3, then sine has to be the bigger one, root 3 over 2. If it's 1 over root 3, then cosine has to be the bigger one. Okay? All right. Anything else? Okay, so let's move this way. These are a little weird. So what I'm going to do is first of all, in the most ideal situations, arcsine of sine just cancels out and you're left with the angle measure. That is the most ideal situation. So the most ideal situation, so what do we need to be careful about here is principal values. In our most ideal situation, the sine to -1 to sine cancel. And you're left with what's in the box. That's our most ideal situation. So I'm going to show you one where the ideal situation works out, and I'm going to show you another one where the ideal situation does not work out. It's like what inverses are, it's kind of like, let's go back to like we learned multiplication and division a long time ago. If I take 3 and I multiply it by 4, to undo that, if I multiply by 4, if I divide by 4, where am I? I'm back at 3, right? So if I do 12 divided by 4, I'm back at 3. So I started at 3 and I ended at 3. Those two cross each other out, right? The times 4 and divide by 4 undid each other. That's what's happening with the arc sine and the sine. They undo each other. The only danger is if the angle is not in the proper quadrant. They're very picky. So this angle is in which quadrant? So I've got 0, I've got pi over 2, I've got pi, I've got 3 pi over 2. Those are my quadrants. It's in the first quadrant. This angle measure is in quadrant 1. Is sine allowed to be in quadrant 1? Is sine allowed to be in quadrant 1? Arc sine. Yes. So this is the perfect situation. It's allowed to be there. So we're going to net, they're going to cancel each other out, and our answer is going to be pi over 8. This is our ideal situation. Pi over 8 is in the first quadrant. Arc sine is allowed to be there. We're great. Now I'm going to show you a not ideal situation. We're going to call this letter E. I'm just going to add a problem. So let's say I have this problem. So we've got cosine, arc cosine of cosine to the negative 2 pi over 3. Okay. So the first thing I need to figure out is where that angle is and if cosine is allowed to be there. So I guess the first thing we need to decide is where's cosine allowed to be? Arc cosine is allowed to be in the first and second quadrant only. That's it. So if that angle measure is anywhere but the first and second quadrant, we're going to have to move it. Okay, so let's figure out where it is. So let's do this. So this is the 6th, right? This is one of the 30, 60, 90s. So I've got negative pi over 6, negative 2 pi over 6, negative 3 pi over 6, negative 4 pi over 6. That's it, isn't it? Negative 4 pi over 6 is the same as negative 2 pi over 3. Which quadrant is this in? 3. Are we allowed to be in quadrant 3? No, we are not. We are not allowed to be in quadrant 3. That's where the angle is. It's long along the y. What is x in that quadrant, positive or negative? Negative. Where is the proper quadrant for cosine to be negative in? 2. The proper one is 2. So we need to figure out what is this angle measure where it's long along the y in quadrant 2. We need to be in quadrant 2. That's where we need to be. Why do we need to be in quadrant 2 instead of quadrant 1? Because this angle, at this angle, x is negative, right? X is negative down there. We need to go to another quadrant where x is negative. We need another quadrant where x is negative. That's what we need. And the only one that fits that bill is quadrant 2. We need quadrant 2. Is everybody with me on why it's quadrant 2 and not quadrant 1? Okay. So I need to mimic that relationship. I need the y value to be long or big, and I need the x value to be shorter. So it's this. All right, so now let's count around that way. So this would be 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. So the proper angle measure is 4 pi over 6, which reduces to 2 pi over 3. So 2 pi over 3 is the proper angle measure. Now, I will tell you, it's not as simple as just taking the negative off of the original angle. That only works with cosine. It doesn't work with any other trig function. Why? What is something we learned about cosine and a negative argument? Do we remember? Remember the even odd properties? Remember that? Cosine is even, and cosine of negative theta is the same as cosine of theta. Remember that? That's why it works for this one. It's not going to work for anything that's not even, so please don't think you can just erase the negative and you're good to go. That would only work with even functions like cosine, and the only other one is secant, and we won't be working with secant yet, so don't try it on anything else, okay? All right, is everybody okay? All right, let's move to, we have 2 more problems. So find the inverse. Okay, great. We know how to do that, so let's rewrite this as y equals 2 sine of x minus 1. The first step in finding the inverse is switching the x's and the y's, right? So I switch them, so I have x equals 2 sine y minus 1. Now, if you recall from the very first problem that we did, we're supposed to isolate y. We're supposed to solve for y. So I want to get the sine y by itself. So I'm going to add 1 over. So x plus 1 equals 2 sine y. And then I want to divide everything by 2. So I have sine of y equals x plus 1 over 2. All right, I'm very, very close. What I'm going to do is I'm going to pull this out. So I'm going to kind of write it bigger, leave some space in here because I'm getting ready to do something to both sides. We know with an equation we can do whatever we want as long as we do the same thing to both sides, remember? We've been working on that with that for years. So I'm going to actually arc sine both sides. I'm going to sine -1 both sides. And our sine -1 of sine, remember they cancel each other out. I'm left with y equals, or we're going to call it y to the -1 because it's the inverse. Inverse sine of x plus 1 over 2. Okay, I want to pause here for a second. We have completed our first task and we have found the inverse function. Is everybody okay? Okay. Now they want us to find domain and range. Now this is kind of weird. I'm just going to give you the heads up. To find the domain, we want to know the x's, right? Domain is the x's. So I'm going to take that x plus 1 over 2. And I know that sine goes from -1 to 1 because that's what it does. How do I know that sine goes from -1 to 1? When we graph sine, remember how the amplitude is 1 and it went up 1 and down 1, right? Sine goes back and forth between 1 and -1. Now I need to solve for x, so this brings us back to last year's work with inequalities. The first thing I want to do, I want to get x by itself, so I want to get rid of the 2. The 2 is a divider, so if I undo that, I multiply everything by 2, we're good to go, right? So let's multiply through the whole thing by 2. So -2 less than equal to x plus 1 less than equal to 2. Okay, great. I still want to get x by itself, but I have a plus 1 in there, so I'm going to do the opposite. I'm going to subtract 1 from every part. So -2 minus 1 is -3. And 2 minus 1 is 1. So this is my domain. That is my domain. That is the domain of f -1. Okay, the range is just going to be the same thing. Okay, so the range is just going to be -pi over 2. Oh, that's a y. Pi over 2. Now, I want to caution you because this was confusing some ladies earlier, because on the homework, it's playing a trick on you. It makes you find the inverse function. Okay, no worries. Then the homework says, what is the range of f? It says, what is the range of f? Okay, that's really not very nice. What it should be asking is, what is the domain of the inverse? So the range of f is equal to the domain of f negative 1. And this is what you should be doing, which is that thing right there. Some ladies were tricked and put in negative pi over 2 over pi over 2. Well, I can understand why that would be tricky. They weren't asking for the range of the inverse. They were asking for the range of the regular function, which means the domain of the inverse. See how they were doing a play on words? Sorry about that, but that's just, I'm just warning you. I'm giving you the heads up. Don't be tricked. Okay? Our last problem, they want us to solve. That's a big key word for us. What does it mean to solve? What does that mean? Can somebody tell me in words? What does it mean to solve? Yes, to get the value of x. That's what it wants us to do. It wants us to figure out what x is, which typically means solving for x, right? That's what we're doing. Okay, great. So I want to get this part by itself, the thing with the x in it. So I have, and I'm going to do, instead of sine negative 1, I'm going to write it as arc sine. I hope y'all are okay with that. I just prefer that notation. So, okay, great. So pi over 3. So that takes us to a concept we need to think about. So where is pi over 3 is right here. So that's a 30, 60, 90, right? 30, 60, 90. And it's bigger along the y. So what number should we be thinking for bigger along the y? For 30, 60, 90? Root 3 over 2. The answer is root 3 over 2. So x is root 3 over 2. Okay, how are we doing? Is everybody okay? Okay.